Let's begin by setting up our environment. We're going to use UV. Make sure you have it installed by running the pip install command. You can use pip if you want, but UV is much faster. Next, we initialize our project with UV init command. It's going to create some files for us. Next, we have to install all the dependencies that we need, mainly Langchain and PDF, so we can extract text from our PDF file. Now we can begin writing some code. Let's first import Ollama. I better switch my virtual environment here. Since we are going to work with Ollama, make sure you have it installed on your computer. To be able to invoke models, you have to start the server with the Ollama serve command. Then you can list all the models on your computer. We are going to use the Llama 3.1 model. If you don't have it, you can easily download it with Ollama pull command. I forgot to install the Langchain community package. Make sure to install it also. We will import the PDF module, which will help us extract PDFs to raw text. Now I'm going to initialize our LLM. I'm going to pass the Llama model as the model parameter and set the temperature to 0. Temperature value of 0 means that the model responses will be very deterministic and will not vary. If you wish to receive a more creative and varied output, set the temperature higher to your liking. Next, we initialize the loader. It takes file path parameter, which will be the name of the PDF file that we are going to work with. I found an IBM annual report file that I'm going to use in this example. We simply pass the file name as the parameter. You do have to make sure that the PDF file is in the same directory as your Python file. To extract the text from the file, call the load method. The output will be a list of document objects, each representing a PDF page. Let's print the length of the docs variable to see how many pages we are working with. "146. That's a lot. I'm going to grab the content of only 10 pages. That will do. In theory, Llama 3.1 should be able to handle it considering its 128,000 token context. But this would burn my PC, so I'm going to be careful this time. Now I have pages variable as a string containing all the text from the first 10 pages. Let's print it and see how it looks. Okay, now we are ready to give this text to our LLM. The way we do it is by setting a system prompt first. We create a messages array made up of 2 tuples, first tuple outlining the instruction for the model and the second carrying the text. Now we simply call the invoke method on the chat Ollama object. Langchain makes this very easy for us. Let's see what the response is. All right, here is our summary. Looks good. Let's try something else. Let's say we want the AI to tell us the sentiment of that PDF file. Let's say we want a very structured response each time, always consistent, so that we can send it to the client who can render it in an app or something. To do that, we're going to use Pydantic. Pydantic is the most widely used data validation library for Python, and it makes it really easy for us to describe exactly what response we want to receive from our model. First, let's import Pydantic from the Langchain core module. Now let's describe the model. I'm going to call it simply result. It will have a sentiment value, which will be type string. I can further utilize the field function with description parameter to explain what exactly I want to be stored in this value. All of this will be parsed and sent to the AI model, so let's be sure it is clear and explanatory. Next, I want to include a score value of integer type. I want AI to evaluate the text and let me know how bullish or bearish the report is. With our schema created, we are almost good to go. One last thing is to call the withStructuredOutput method on your barebone LLM model and pass the schema as a parameter. Make sure to invoke from the structured LLM object so that it will work. And here we go. We got our score, just like we wanted. Thanks for watching.